So what we've just discovered is that a truth table is meant to represent a state, or a truth table is actually meant to represent all possible states on the Boolean variables that are listed. But we know that a state is by definition an infinite table. So how is it that we can construct these truth tables, which are finite tables, to represent all possible states of well-formed formulae? Well, what is it that we're doing when we're constructing a truth table? Well, we're considering only the Boolean variables which occur within the well-formed formula and then applying the Boolean functions. So, essentially, the reason that we have these finite tables is because intuitively we know that the value of a formula in any state should depend only on the values of the variables that occur within that formula. So essentially what we do is only consider the variables within the formula, look at their truth values according to each of the states, and calculate the truth values of the formula A. So what we do is truncate the state into a finite appropriate table. And it can actually be proven that if two states agree on the variables of A, then they are equal. So it's enough to consider this smaller finite table based only on the variables that occur within A, because essentially for the variables that don't occur in A, their states or their different truth values do not impact the truth value of the well-formed formula. Much like the truth values for top and bottom are the same no matter what state we're talking about, so we also don't have to consider those. The proof of this proposition is outside the scope of our course, but it is important that we recognize and know that there is a formal proof of this result so that everything that we're doing within this class and everything that's done within logic, again, is properly well defined so that it does not create any contradictions or paradoxes. Okay. So one thing that you may notice here is that this word occur is underlined here. So again, to make things rigorous and formal within this course, we need to simply define what we mean by a variable occurring in A. So again, we define this according to the formula calculation for well-formed formula. So in the atomic case, right, that first case of the formula calculation where we just add Boolean variables and constants, we define what it means to occur in one of these atomic formula. So we say that P occurs in the formula P, so P occurs in itself, but it does not occur in any other Boolean variable different from itself, nor does it occur in top or bottom, and we define occurrence of a variable, not a constant. Okay, then the next step, P occurs in not A if and only if it occurs in A, right? So in order for it to occur or appear within this well-formed formula defined by not A, we know it must appear or occur in A. And finally, in order for P to occur or appear in A circle B, where circle is any of these connectives, it must occur in either A or B, or it could be in both. So simply occur means that it is there somewhere in the formula. So again, we're just formally defining this, going through the construction of a well-formed formula using the formula calculation. Okay, so finally, we can arrive at defining or reviewing what a tautology is, what satisfiable means, and what a contradiction is. So we define a formula A to be a tautology if and only if it is true in all possible states. And we denote this by this symbol. Okay, so essentially, just as you defined in discrete math, right, when you construct the truth table and you have the value true in each row, then you knew that that well-formed formula was a tautology. Well, since we know that our truth table, each row is a different state, and our truth table lists all possible states, this is the same thing. Okay. We define a formula to be satisfiable if and only if there is at least one state V where the value of that formula is true. Okay, so a formula is going to be satisfiable if it has a truth value of true in at least one row. We define a formula A to be unsatisfiable or a contradiction if and only if for every state V we have the value of A, the truth value of A is false. Okay, so in this case, each row has truth value false. That's when our formula is a contradiction, which again, you would have discovered in discrete math. So this is the same definition, and essentially a contradiction is the opposite of being satisfiable. So the exact negation. All right, so that brings us to the end of what we'll cover in the next section. So please remember to post all of your questions or comments from all of the videos that have been posted for our next class, and I will address each of them in class before we actually apply them to solve problems. And sometimes simply applying and solving the problems will help to clarify anything.